Okay, what's a work cell? This is supposedly going to be an overview of strategic arrangements in manufacturing and beyond. Well, am I the only one that thinks to infinity and beyond when I say that?
Manufacturing and beyond.
Okay, so what is a work cell? It's just a logical and strategic arrangement of resources in a business environment. That's pretty much it in a nutshell. Arrangements are designed to improve process flow, increase efficiency, which is going to reduce cost and eliminate waste. We had a work cell set up at one of the places that I worked many years ago, and we did a time study with the old arrangement and then the new arrangement, and they figured out that their idea for the new arrangement sucked. Like, there was a guy standing there with a clipboard and a piece of a pencil and a piece of pencil and a paper. And anyway, his whole job for that entire shift was to stand there, and when the guy operating the cell moved from point A to point B, he'd write it down. So, if he just went like that, he had to write it down. Can you imagine how boring that was? He couldn't go take a leak. Couldn't. Well, he did get to go to lunch because the guy operating the cell went to lunch, but had to stand there the whole time and don't take your eyes off him. Okay. Didn't blink for like 8 hours.
Why?
They were trying to figure out if that work cell design was efficient or not.
Having someone stare there and watch you all day?
Yeah. Yeah, they called it a time study, so I don't know, probably a tax write-off or some thing, Have two guys.
Then it didn't work.
Have two guys standing there, one of them operating the cell and the other one watching him. It's not exactly the definition of efficiency. Okay, so the concept work cells is based on a platform of lean manufacturing. You guys ever heard of lean manufacturing?
I haven't.
It's a lean manufacturing. The idea behind lean manufacturing is to reduce waste as much as possible. The concept of work cell based on a platform of lean manufacturing focuses on value creation for the end customer and reduction of wastage. Or just waste. I really need to fix that. Is wastage a word? Work cells, which are also referred to as work cells. Did you catch that? It's two words there and all one word there. Work cells, which are referred to as work cells, are typically found in manufacturing and office environments. I've never seen one in an office environment. Work cell is a term used to describe the logical and strategic arrangement of resources in a business environment, including people, machinery, and other equipment. Based on a platform lean manufacturing and in an office or administrative context, work cells may facilitate a better flow of communication and more efficient use of shared resources. Okay, cool. Generally set up to complete a specific activity. Like if you're building widgets, then you have all the parts and machines and the people in that one area that builds the widgets. And then, the phragistats are in a different one, and the canutinators are in a different one, whatever. That works well as long as um, the people that are supplying the materials and whatnot to the cell understand what's going on, so that they supply the correct materials to the correct cell. Cells are often implemented to reduce the cost associated with production and ramp up productivity. Many companies also significantly reduce the rate of error by putting work cells into place. So, there was somebody, I can't remember who it was. With all the technology that we have to make our jobs easier nowadays, if you can get the same amount of work done in half the amount of time, shouldn't the other half of the amount of time be yours?
Yes, I feel like it should.
You know, what used to take 8 hours only takes 4 hours. If I can get my stuff out in 4 hours, I should get to go home. The way I think about it. Well, there is such thing as piecework. Yeah, you get paid so many pennies for every piece that you complete.
Oh.
Yeah. But the corporate mentality is, if we do this work cell thing and we can get twice the production out in half the amount of time, look at all the extra money we can make, because we're going to make these poor suckers work the full 8 hours anyway. And we're going to quadruple our production. So, yay, technology. In a manufacturing facility, the machines involved in the production process would be arranged so that the goods being produced move smoothly and seamlessly from one stage to the next. You ever think about an auto assembly plant? That's probably the prime example.
That type.
Yeah. You know, you start out with a frame at this end, and by the time you get to the other end, you got a car or a truck or whatever. That is a prime example of things moving smoothly from one stage to the next. You know, you have to, I don't know how, the order that they assemble cars in, but they, start with the frame and they assemble the body and put them together. And, you got powertrain and wheels and brakes and electrical system, and somebody's got to put the dash in and windows and put the hood on, get it all straight, and so it latches properly and the body lines look good, and all that stuff. That's all done, thought out very methodically on what is the best way to go from nothing to a full car. Cellular manufacturing process, which is a subsection of just-in-time or JIT manufacturing, and lean manufacturing encompassing group technology. You guys know what JIT is?
Yeah.
Just in time.
The Japanese affected that art.
Yeah.
JIT.
That way you don't have.
Yeah, just in time means that their process is so meticulously designed and streamlined that they know that they're building this car on this day in this plant with these options. So everything upstream of that, the supplier that is providing the parts to the auto manufacturer and the distribution system, the trucking and all that stuff are set up so that when that car is moving down the production line, that's when the stuff shows up on site to put the car together with. They don't store anything in a warehouse. Cellular manufacturing involves the use of multiple cells in assembly line fashion. Cells created by consolidating the processes required to create a specific output, such as a part or set of instructions. Allow for the reduction of extraneous steps, which that's what that time survey thing was about. do you have to walk around this machine, or, is the stock rack in the right place? So when you're ready for that tube or screw or whatever it is, is it there readily available? Do you got to walk all the way over there to get it? All kinds of crazy things. So let's say a firm that assembles air handling products faces high inventories and erratic delivery. It originally assembled units on a traditional production line. Long setups and logistics required long production runs. It often found that it had to pull products from finished goods and rebuild them for custom orders. So can you imagine finishing a product and then getting a custom order, and you had to take the thing you just built apart so you can make something else out of it? What a huge waste of time that would be. Using lean methodology, company assembles cells to include 12 small 1 to 3 person assembly work cells, always set up and ready. People now work in different cells each day and assemble products per customer orders. Finished good inventory dropped by 96%. Lead time was 24 hours. Productivity improved by as much as 30%. So when I first read that, I thought, okay, 1 to 3 people always ready, always set up and ready. Does that mean that if you don't have an order for that particular product that day, do those 1 to 3 people just sit there like bumps on a log and do nothing?
Probably.
Well, then I read the rest of it, and it says that people now work in different cells each day. So if we're building widgets today, we work in this cell, and if we're building Pragostats, we work in this cell. Just because the cells are sitting there ready to go doesn't mean there's actually somebody just standing around waiting for an order to show up. Using work cells in manufacturing facilities. Okay. Critical part of manufacturing facilities. Work cell is a specialized arrangement of people, equipment, tools, materials, everything we've already talked about. Improve the quality, speed, and cost of the production process. Anything that you can do to reduce cost increases profit. Work cells are designed to complete the manufacturing task in sequence. That's the main key to a work cell. Group technology classifies similar parts or products into part of product families so they can be matched to manufacturing tasks. The layout of a work cell can provide simplified material flow, minimal transportation distance, promote communication, and enable a single piece flow. Promoting communication is probably one of the weirdest things that I think on that list, because if you're talking about, hey, get ready, I'm going to hand you the next part, that's one thing. But whenever you promote communication, people end up standing around shooting the breeze about, who won the ball game last night and all kinds of other things that I think would tend to slow production down rather than speed it up. So, work cells can include manual automated equipment. Almost always it's automated, at least to some degree. Even a punch press, you put the raw stock in there and step on the pedal and the press does everything else. That's kind of a automated manual step, I guess. Manual machines are run by a single operator. The cell could have a U shape, so you think of a horseshoe. If you're standing here and you do this operation, and you turn around here and do this operation, turn around here and do this operation, that kind of thing. Automated cells can include robots and or other automated equipment. Operator could be working an automated welding cell, automated welding machine, and a turntable. The neat thing about robotic welding is they always weld exactly the same way every time. So it's you don't have the variation that you would get from a human welder. So many of those, there is a turntable of some sort. There's a jig on both sides. You jig up all the pieces, push the button, the table turns around 180. While the robot is doing its welding on the parts that you just put in, you take off the finished piece, send it on down the line, and then rejig for the next one. When the robot is done, you push the button, it spins back around the other way, and the process goes all over again. It's a very efficient way to do robotic welding. You just have to have somebody that knows how to recover from any faults that show up on the robot, because they do happen. You also have to have somebody that knows how to weld, believe it or not. Any idiot can jig up the fixture and push the button. But when they pull the finished part off, they're looking at the welds to make sure that they were done correctly, good penetration, no porosity or big hunks of slag or whatever. Another example is a robot being used to weld at 2 different welding stations, employing a robot shuttle. That one I've never seen, but as I understand it, the welding stations, one would be here and the other one would be here. So while the robot is over here doing its welding, you're setting up this one. Whenever the robot gets done over there, you push the button, the robot comes over here, starts doing the welding. As you walk over here, take off the finished part and start jigging over here. That would require the robot to have a 7th axis. So it can always go to the same place every time.
You have the what axis?
7th.
7?
Yeah. Most robots are typically 6 axis. Unless it's a palletizer, then they only have 4.
Axis like AXIS?
AXIS, yes. With a flexible manufacturing welding system, FMS, FWS, flexible manufacturing system, each part arriving on a pallet will be recognized by the supervisory controller of the cell. The asking robot controller will automatically call up the right program. The cell controller also handles loading and unloading sequences. So you can actually have a separate robot that loads and unloads. So you don't have to have the person standing there, 'cause what if it's, frame for a truck? Some of you guys are pretty burly guys. I don't see any of you picking up the frame of a truck. Design process for a work cell includes logic. You got to think about what's supposed to happen. Robot trajectory, planning out a robot's behaviors within the work cell, including speed, position, action, and how it relates to other devices within the cell. Robot, if you tell it to go from point A to point B through point C, it's going to do it. So you have to know how the robot is going to work. You have to go around point C. It doesn't run into it. Any of you guys in Landon's robot class now? I know Aiden is. Have you guys talked about robot motion in the, say you're if you have some obstacle in here, you want to get from point A to point B, you have to go through point B to get there. the faster you go, the shorter that arc becomes. Okay, that's what this is talking about. I/O mapping, creating a schematic or chart which indicates each of the input and output connections between the work cell processor, PLC, robot, CNC, etc., and their devices. A work cell typically has everything interconnected, so all the machines talk to each other. So, you guys ever watch the Robo girl out here make the fidget spinners? Actually watch it. The robot there is only there to tend the machine. It takes the raw parts or the raw stock, puts it in while the robo drill is doing its thing. It just sits there and waits. And then when the robo drill is ready, it says, "Hey, robot, I need tending." Opens up the door, robot reaches in, flips the part over, and does all kinds of other things. Yeah, they're actually talking to each other. In that case, it's over Ethernet. Cycle time is elapsed time between work cell starting and completion. There are some places that are so devoted to minimizing cycle time that they worry about milliseconds or thousandths of a second. You know, okay, so it took an extra couple of milliseconds to do that. Yeah, whenever you talk about over the course of a year, a couple of milliseconds is, you know, can be a significant amount of time. So again, that's the corporate mentality. You know, how can we shave time off this? How can we shave time off this? You know, the less time it takes us to do it, the more of them we can do in the same amount of time, more money we make. It's all about the Benjamins. Work cell design and development process is often completed using virtual simulation and offline programming. Can you imagine having to design a cell as you're running it? Well, of course they're doing it offline. The neat thing about, you guys ever been to the VR lab upstairs? Either?
We have a VR lab?
Yeah, there was also.
It's right up at the top of the steps. Virtual reality.
Let's go in there.
Well, you have to talk to Renee and say, "Hey, I would like to see the VR lab." And
Ask Renee.
Renee is in the Renee Wade. She's in the classroom right next door to the VR lab.
She's a superhero.
Yeah. Not for VR, about.
Oh, about.
So design virtual model of the work cell. We have a robo guide that we use sometimes. And you can actually create a complete work environment with all of the parts and pieces and bibs and bobs and the robot and the tooling and the fixturing and all that stuff. You can do it all virtually. You can get the robot programmed to do what you want, when you want, where you want, and all that stuff. If Kabili was here, he would be able to tell you he actually spends a lot of his spare time doing that kind of thing, just for fun.
For fun?
Yeah.
Oh.
Yeah, Kabili is extremely intelligent.
So is that kind of like what Landon uses?
The in classroom stuff, yeah. Yep. Need to outline trajectories, download programs to the robots, after the completion of the design, and then you're going to spend time debugging. There's an old saying, if you programmed it right the first time, you took too long programming it. And there's not something that you screwed up that you have to, a bug you have to squash, then you took way too long to do it. Programs can also be used to design the work cell for operator safety, ergonomics, and human factors, and help determine cycle time. Ergonomics is really big deal for OSHA these days, because well, that and the insurance companies, they don't like paying for carpal tunnel surgeries and rehab and all that stuff. And isn't my robot cute? The neatest, like, cutest thing you've ever seen. Work cells are set up so that a robot or robots can complete multiple automation tasks in a singular area, making for an efficient, cohesive automation process. Robot cells have become a major part of almost every manufacturing industry, offering their users many benefits by reducing labor costs and performing difficult repetitive tasks so the workers don't have to. That's one of the main things whenever people start talking about robots coming in to do, I'm going to lose my job because the robot's going to take over. Well, while that is technically true, you still have to have somebody to work on the robot, program the robot, so hey, let's skill you up so that you can do those functions and let the robot do all the hard work. Would you rather carry this from here to there 5,000 times a day or let a robot do it? If you got you're palletizing 50-pound bags of gravel or whatever, that's hard on a man's back. Industrial robots generally considered to be accurate, durable, long-lasting, and dependable, as long as you don't ask them to do more than they're designed for. They will typically not let them destroy themselves, but there are ways to turn those features off. Don't. Industrial robots are capable of operating within a wide range of manufacturing tasks, including working with heavy construction equipment, the sensitive microchips and electrical components. Common features of a robotic work cell. When it comes to robot work cells used by industrial robots, these cells have a general setup and flow for most applications. The manufacturing process, raw materials, to be assembled, shaped, welded, moved, palletized, types of jobs that industrial robots excel at because it's the same thing over and over and over again. Any process that's repetitive is often a good candidate for robotic integration. Repetitive, dangerous, got to move heavy things, that sort of stuff. There's most places where you have to handle heavy objects, though. There's some kind of a lift system or something that assists you in moving.
Seems like a perfect.
Yeah, anything that requires high speed and precision is a good robot thing. I say, anything that is repetitive over and over and over and over and over again makes you want to run up down the road screaming. The robot doesn't care. It'll do it all day long and just love it to death. The dangerous thing is one of the big things that the robots are very helpful at, because you don't have to worry about lead poisoning or well, I guess you dump acid all over them, they probably wouldn't appreciate that much, but still, you can replace a robot a whole lot cheaper than you can replace a person. So once the cell is integrated in the plant process, materials or goods that are needed need work to be done to them are presented to the cell in some fashion. A lot of times, you have robotic transports too. Once the robot has control over the process and it does its work, the work is completed, the manipulated part is removed either by another robot or some type of system, often a person. Process is repeated. The goal of industrial robotics is to reduce the number of human hands that touch product from start to finish. So the more things you can have the robot do, the better. It eliminates human error more than anything else, unless a human made an error programming the robot. Robotic cell is much more than just a robot that sits in a manufacturing plant. In fact, robotic arm by itself is almost useless. I would change that to is completely useless. Without the controller, it is just,
It's just an arm,
yeah.
nothing to
It's like, without your brain, this is just an arm.
brain, dead arm.
Yeah. The controller on the robot is the brain. In addition to the robot, though, there are a myriad of sensors, motors, pistons, PLCs, and other components that help to assist the robot in its operation. Common components in most industrial cells include end-of-arm tooling or EOAT, PLC, motor, sensor, that kind of thing. End-of-arm tooling, that is what is affixed to the end of the robotic arm, and it's the link between the object receiving the work and the arm doing the work. So think gripper, suction cup, fork for going under a pallet, picking it up, that kind of thing. Paint. Robots are really good at painting. Cars, trucks, tractors, whatever. PLC, often used in industrial cells to control processes that are within the cell but out of the scope of the robotic control unit itself. PLC acts as the brains of the cell operating around the robot. Motors, drives, and sensors, often used throughout the work cell, move certain components and relay information about them. Motors are mostly controlled with drives that are linked to a PLC or the robot controller. In order for it to be linked to the robot controller, it has to be another axis on the robot. Sensors use relay information about the cell to the robot. Most of that is the part there or not? Are all the safeties clear? Are there any humans in the area? That kind of thing. Yeah. In effect, the sensors are the eyes of the robotic work cell, often useful in primary stages of quality control. Can be used to reject defunct parts early in the process, saving time and money downstream. The level of sophistication of sensors nowadays is just absolutely astounding. They can detect welds based on the color of the surrounding material to be able to tell whether it was a good weld or not. They use ultrasonic and all kinds of other NDT, non-destructive testing. As they're actually performing the welds, they're monitoring everything as it's going. So if the robot has a screw up mid-weld, you can actually detect that and it'll reject the part. If you're doing high-speed packaging, and a label is on crooked, or a lot of them can sense the level in a bottle. I mean, there's just insane amount of sensors out there that you can use in your process. You can reject bad parts before they ever get into packaging. Robot safety. Since the beginning of the Industrial Revolution, the factory has traditionally been a dangerous place with powerful machines that can easily hurt workers if not properly protected. Industrial robots have safety features built into them from the time they're manufactured. Components. Robotic work cells optimize manufacturing while also enhancing the functionality of industrial robots. Overview. Barriers. Barriers of the work cell determine or define the parameters of the cell, as well as enclose the robot itself and any peripheral equipment. Barriers may consist of solid metal panels, completely block, protect workers, or wire mesh, a fence type thing. Some of them also use just regular light curtain, pressure pad, there's all kinds of different things that you can do. Anything that involves UV, heat, fumes, debris, i.e. welding, those are typically fully enclosed. Either has the turntable where you're never exposed to the actual operation, or fully enclosed where you have interlocked doors that if the robot's in operation, you cannot open the door. You have to stop the robot before you can open it up and enter. Robot is the main component of any work cell. Can house one or more 6-axis robots. Mounted overhead on the floor on a riser. For assembly processes, Fanuc M20IA may be selected. Robotic arc welding will require an ArcMate 100 IC or similar. So a different robot for different job. Safety equipment, again, many safety measures to ensure operation of the robot and protect the operator or just anybody happen to be walking by. Peripheral equipment. The end of arm tooling on any robot is considered a peripheral. That's not part of the robot itself, believe it or not. Doesn't matter whether it's a vacuum cup, actual gripper, paint gun, MIG weld gun, whatever. It's not part of the robot itself. Operator station. All robotic work cells are equipped with an operator station, also referred to as ops. An ops station is an external control panel located on one of the cell barriers. Control panel controls operation of the entire work cell, consists of 6 to 9 buttons. Main one is e-stop. Oh shit. Reset, hold, cycle start, that kind of thing. Operator stations provide user-friendly interface to simplify the operation of the robot cell. So you need to tell the robot to start doing its thing, you press the button that says go, and the robot takes care of everything else. And that, ladies and gentlemen, is that.